Okay, as an introduction to statistical parameters for the joint distribution, I'm going to use the following example. Now here we have a drug treatment program, and I have an array that's arranged as a joint distribution of two variables. Here we have the recovery times of case patients based on rank. Here are the cases that recovered with rank 1, recovery with rank 2, and recovered in the program with rank 3. And here are the drug treatment dosage is the other variable. This row represents the cases that received 10 milligrams of the dose. And this row represents the cases that received 20 milligrams of the dose. A first step in working with a joint distribution array is to compute the row and column sums. These are all called, mathematicians call these marginals. And this will help us with the upcoming analysis tools that we will use soon enough. So here we go. I'm going to first do the R variable recovery. I'll add each column and put a value at the base. As you can see, 14 cases received a recovery 1 rank, 18 cases received a recovery 2 rank, and 25 cases total received a recovery rank of 3. The other margin would be to add row-wise across within the array cells. We have 32 cases received a dosage of 10 milligrams, and we see that 25 cases received the dosage of 20 milligrams. What's also useful is to, as a mini checkpoint, is to add up the total number of cases, should be 57. And as a checkpoint, I can also add the columns, make sure that adds up to 57. It's 32 also plus 25. And I know that my total is 57 cases from this study. The second array is set up as what's called a PDF, a probability distribution function. And I'm going to leave it in fractions, even though my work will also use decimals. So just as an example, say we have 57 cases, that becomes the denominator in the cell. So I'm going to split each cell in half. If we were to make these into a decimal, for example, 13 out of 57 is kind of close to 14/56, which is a quarter. So about the quarter of cases are right here in that cell. They're right there. But what I'll do is I'll also show the margins, but I'll leave it as a fraction because sometimes it's easier to work in fraction form when we're doing mathematics. Notice that when I add up the fractions, say these were in decimal form, they would add up to 1, because look at the numerators, 32 plus 25, well that's still going to be 57, but since we divided by 57, that cancels and becomes 1. And also this way, if we add up these numerators in pieces of 57, see altogether there's 57 of them too, and so that adds up to 1. The first variable that we can work with is what's called the expectation. This serves as a prediction for a case based on like a statistical mu of x. And we do that with a PDF by using x times p of x, and we sum that and we get our expectation. So with respect to the recovery ranks, 1, 2, 3, that will be those will be my x values. The expectation for recovery for this data set is 1 times the marginal column sums, so 14 over 57, plus 2 times 18/57 plus 3 rank in recovery times 25, 57. So if you do this mathematics with a calculator, you'll find that E of x is 2.19. So what I'm going to do is I'm just going to mark that on top, just to give me an idea if I had an average case. That's 1, 2, 3, a little more than 2. At 2.19 would be my mu of variable r, the recovery variable. Okay, notice that since it's weighted a little bit to the right, with these 3 cases, there are 12 of them, and there are only 10 in the other cells, we get a mu that's a little bit above 2, so that mathematically should make sense. Before we begin the dose expectation, looking at the cases, there are more cases receiving 10 milligrams than receiving 20 milligrams, so I expect that mu will be, well, a little less than 15. All right, and in fact, when we compute the expectation for the dose, we do get a value of 14.38. That actually rounds to 0.39. So notice that, well, halfway between 10 and 20 is 15. Since there are more cases on the 10 side, it pulls that average, that expectation serving as average, to a little bit less than that 15, which would be the midpoint of 10 and 20. All right, so there you have it. Those are the expectations for this joint distribution.